Number 35. So they want the critical points. So we need to take the derivative. I'm going to rewrite this first. Now let's take the derivative, and it's a product rule because you're multiplying two things. Now these are kind of difficult to, after you take the derivative, it's kind of difficult to work with, and we'll talk about that. You guys need to get better at factoring. So I'll take our time. You leave the first alone, and you take the derivative of the second. Well, this is not x to the 1/2, it's box to the 1/2, so it's chain rule. So it's going to be 1/2 in front, box, subtract 1 from the exponent, you get negative 1/2, times the derivative of box, but this time it's just 1, plus, we're going to leave the second one alone and take the derivative first, which is 2x. Now we will simplify this a bit. So we have x squared, x plus 1 to the negative 1/2 over 2 plus 2x, x plus 1 to the 1/2. Now there's two ways to factor this. And I'm going to show you, I'll probably show you both ways because we have time. So what do they have in common? You should see that they both have an x plus 1 and they both have an x. And then we normally don't like fractions, so we're going to take the 2 out because believe it or not, there's a 2 down here. Do you see it? You don't see it, do you? There is one. Let's get a common denominator of 2 over there. So if we get a common denominator, it's going to be 4 over 2. So that will get rid of our fractions in the denominator and everything will be much prettier. So what are we taking out? We're taking out 1x. Why 1x? Because this one has 2 and that one has 1. We always take the smaller amount out, so we're going to take 1. We're taking the 2 out, so the 2's coming out also. And there's also x plus 1, but what are we taking out? There's a negative 1/2 there and there's a 1/2 there. We take out the smaller amount, which is negative 1/2. So what are we going to be left with? We took the 2 out. Let me change the color of that. We took the 2 out. We took one of the x's out, and we took all of that out. So we're left with just x. Here on the second one, we took the x out. We took the 2 out. Those are gone. We're left with a 4. We didn't take all of that out. So we're going to be left with x plus 1. But here's a part that some of you might struggle with until you process. So this again, if you're confused about this, what I'm doing here, you need to look at this, relook at this, and figure out why I have a 1 here. You have to go back to the properties of exponents from algebra. Why is that a 1? You have to understand instead of just moving on and saying, oh, well, that's confusing. Sucks for me. Now, when you multiply this times this, better gets you that. And I think you can double check and verify that. This times this better gets you that. There's my 4, there's my 4. There's my x over 2, there's my x over 2. But how do you deal with the x plus 1s? They are exponents with the same base. The rule is that plus that must equal that. Negative 1/2 plus what equals 1/2? It's going to be 1. That's why it's a 1. So now let me do all the beautiful stuff. X is on top. This will give me 4x plus x is 5x. So that's going to be 5x. And then distribute that 4, you're going to get 4 all over 2. And the negative exponent moves it to the bottom, is square root of x plus 1. I hope all that's right. I hope it is. All right, at this point, we need to find the critical points. That's when this derivative is 0 or does not exist. When is a fraction 0? When the numerator is 0. The numerator 0 is when x is 0 or 5x plus 4 is 0. So we got one critical point there. Solve for x, negative 4/5 There's your second one. And when else we have a critical point? When the denominator equals 0, because that's when the derivative does not exist. So that's when radical x plus 1 is 0, or x plus 1 is 0, or x equals -1. So it looks like that's our answer, but we have to now look at the graph of this also.